Sure, yeah, totally, 100%. Yeah, tomorrow office hours is fine. Or even before school. I'll be here before school. Because we have back to school night, but I don't have a meeting tomorrow morning.
Yeah.
Yeah, if you want to sleep in, come office hours after school tomorrow's fine. Not a problem. So. Okay, guys, quiet. Let's get moving here. All right, so I'm gonna give my voice a break because I feel like I'm about to lose my voice, and I gotta talk all night tonight. Back to school to your parents. So, so Lucas, can you read the opening part of the notes? What is a relationship? So where it says 213. Great, thank you. Oh, sorry, you're still reading. My apologies. Yeah, thank you, Lucas. I appreciate it. So if you look at like which ones could be the same, which pairs do you think would be the same? And there are two such pairs. Which one do you think? Faith Gut? Correct. And what else? Correct. Thank you. So just so you know, for C and D, that relationship is called vertical angles, which was mentioned in the previous topic or previous section. Vertical angles. You can go call it. Sorry. And then for the last option, we call that isosceles triangle. When you have two sides are the same, guess what? The angles opposite them are also going to be the same. That's always going to be true. The markings indicate that these sides are the same, so we anticipate that the angles opposite those sides must also be the same. Okay, so that's same. Which of these, or what do you think the relationship is for A and B? Go, Connor.
I think it's supplementary.
Yes. So that will be supplementary. That means when you add up to 180. I'll just abbreviate as supplementary angles. Add to 180. That's the relationship there. Because they form a line. That makes sense. So A, for example, were 100, if A were like 70 degrees, B would be 110. And then lastly, we say, Maggie, go ahead. Complementary, right? And be careful not to paste one a compliment. That's with an I. That's a little different. More to complement, like for example, French fries complement a hamburger, or maybe if you're a really anxious person and your partner is a really calm person, you guys will compliment each other. Maybe I don't know. So it just means to go with. So F goes with G to add to 90. So Lucas, go ahead. Yeah. Oh, sure. Yeah, no problem. Yeah. It's at to 90 degrees. Okay. Let's keep on moving. 214. So this was great. Kira, can you read 214, please? Yeah, thanks.
View the interactive e-tool about Marcos tile patterns. Translate parallelograms to create a tiling pattern. Consider if each parallelogram is a translation of another, what can be stated about the angles in the rest of Marcos tiling. Consider the angles inside a single parallelogram. Which angles must have equal measure? How can you justify your claim? B2.
That's okay. Thank you. I haven't played with this yet, so I don't know how this is gonna go. So let's keep our fingers crossed. This demonstration is a good one. What is going on here? Okay. So, oh, okay. Can I rotate this? I'm not quite sure. Oh, okay, hold on. Oh, okay. I'm just playing around. This got no clue what I'm doing right now. But well, here's the thing. Okay, now I know what's going on. As I keep sliding this, does the shape ever change? No. Well, no. Each individual parallelogram does not change. Actually, let me refresh this. Now I know what's going on because I was like so confused. Okay. Oh, now I know what's going on. Okay. So as I do the translation, if I put the yellow back here, did the angle change size?
No.
No, stay the same. It's okay. So as I keep doing a bunch of new parallelograms, every single one is always the same. Okay, now I understand why they have this. So now let's go back to the notes. I got it now. All right. So what can we consider here? Which angles must have the equal measure? It seems as though the angles opposite of each other are going to be the same. Okay. So opposite angles. I'll abbreviate for that. Opposite angles. And likewise over here. And how can you justify your claim? We actually could use vertical angles. And here's the reason why. Going back to that demonstration. Aren't those the same?
Yeah.
And then obviously, if I do another one here, those are the same, and I bring this over. Same, same, same. So what we're noticing is that we're getting opposite angles that are all equivalent. So that's what's happening there. Fifth, go ahead. Yes, and we're going to get to that. Yes, 100%. Right, when you do have a parallelogram, that's really the true reason. So if you got this here, these are parallel. And ultimately we'll talk about parallel lines and lines that go through them. And we'll investigate these angles protein form. We'll get to that. Yeah. That's why it's actually called parallelogram, because you got parallel sides, right? Now, what's the relationship between the lines? Obviously, they're parallel. We know this. Can identify which ones? Yeah, it's opposite sides. So we got all that stuff. And so that's how a parallelogram is defined. Actually, the true definition, I'll put it down here. A parallelogram is a quadrilateral in which two pairs of opposite sides are both congruent and parallel. That's the definition of parallelogram. I'll let go ahead. Sure, yeah, of course. Yeah. So now what we're doing is we're diving deeper with these shapes. We talked about all these shapes in the last unit. Now we're diving a little deeper with parallelogram. Let me freeze the screen while I get the next part of the note set up. Okay, so now we're going to look at 215. And while some people are still jotting stuff down, Peter, can you read 215, please?
Wait, what?
215, the bottom of the page.
Really want to learn about the marker diagram. I decided to focus on just the part that is the large view of section is shown in the image.
Great, thank you so much. So if we look at this right here, so we see that LM is parallel to NP. LM is parallel. And those two little lines kind of slanted like that looks like a parallel. It indicates parallel when you see those two lines slanted like that. So those are parallel. So the transversal is what cuts through it. So transversal cuts through, crosses these two lines. So what line cuts through LM and NP?
Okay.
Yep, or JK, whatever you want to call it. JK, I know exactly. Just kidding. Right? No, we're not kidding. It does cut through it. Like that, all right. So which one's a parallel? Well, I already told you. LM and NP. No problem. I can't think of the acronym for LM, but life matters. There you go. Okay. Yeah, there we go. Just kidding. Okay. So, or Lucas's initials. Right? There you go. Okay. Okay, let's move on. So now on tracing paper, actually, I'll just talk about this, guys. We won't do trace paper, just this interest of time. So if you guys were to do this, actually, it would be good that we do, but it's okay. I'll just tell you right now. If you took, guys, quiet, please. If you took tracing paper and actually trace that angle. So I know you guys already had experience with tracing paper. If I took that and then slid the tracing paper up and try to line it up with angle B, you're gonna notice that X and B are the same. X and B will be the same. If you took tracing paper and traced angle X and slid it up, you would see that angle X equals angle B, or the measure of angle X equals the measure of angle B. So again, if you just trace angle X and slid it up, we get that. And again, in interest of time, we won't do the tracing exercise. We'll just kind of keep moving because I know some people have to leave for sports. When that happens, we call those corresponding angles. So angle X and angle B correspond with each other. And that correspondence seems to be pretty apparent with this whole tracing paper exercise, which we're not doing, but that's what's happening. So they're going to be congruent or equal. Connor, go ahead.
The relationship is all congruent.
Yeah, or equal. Yeah, the measures are equal. Yeah. So in the next example, what else will correspond? So I'm going to do this as a little exercise and have you guys fill in the blanks. Okay. So notice the notation. I'm trying to be careful. I'm not, I can't be a little careless with my notation. So remember I said M angle X equals M angle B. So that's where I said the measures. The measures of angle X, like say it's 30 degrees, then angle B is also 30 degrees. Whenever you use the word measure, then you're using equal sign. If you don't use the word measure, then you're just saying the angle itself, like the shape and everything about it. Then use this symbol called congruent, which is an equal to squiggly line tilde above. So if I don't use the word measure, then I'm saying angle D is congruent to this, angle A is congruent to this, angle Y is congruent to this. Kind of these nuances of geometry. So what would be the same as angle D? Given this now, this corresponding behavior is talked about. So angle D is right here. What's that same position down below? D is the same as what?
C.
Exactly. D is the same as E. Let me get rid of this part because it's masking kind of the other letters. So I would say D corresponds to Z 100%. Bless you. D corresponds to Z 100%. How about Y? Y corresponds to what? Go ahead, Maggie.
C.
And what does A correspond with?
W.
Perfect, got it. So those are called corresponding angles. Actually, I like the way it's being taught because it's being very thoughtful and careful. Sometimes when I do teach this or help people with this, they just forget it because all those other terms that come into play and they just get confused. But those are called corresponding. They correspond. Like we see four angles here, we see four angles here, and we kind of have the positions. Now, of course, B and C are vertical. Those are the same. A and B are vertical. So A and D are vertical. They're the same. So I can say A is the same as Z, D is the same as W. There's all these other connections we're gonna make. But for now, to not make it too convoluted, we'll just focus on the corresponding angles. Okay, with that said, go in and try the second half of this page in your table groups. I'll come around and help you guys out. I think you guys can handle this. So go in and try the bottom half of the page. So part B and 217. I'll put the answers up in a moment. And then we'll move on to 2.13 after that. I'll show you the answer key in a moment.
So I don't think.
So what do you guys think about X? Is X cool? Yeah, you see how X corresponds to 135? Okay, now what's opposite of X? 1. So is Y gonna be the same as X? They're both 135. Yep, so we're gonna write that as X are both 135. We write it which one is because X is also X correspond. Yeah, right. Right. So Y was also 135. Okay, let's move on to second.
But then they're corresponding.
Now, what do you think Y is gonna be on the second back again?
Like.
Oh, Y is gonna correspond with the city.
They're the same,
Yeah, to Y.
like, but for this one's like.
Good.
Right.
So what's the difference?
Yeah.
180.
Diagonal from each other, so then they're the same, right?
45, good. So for the second set. Oh, no, we're looking at the second back here. No, we already took care of this one. That one we were. So that's this. Yeah, so we're good for sets. That one, look at the second one now. So the second one, Y is gonna be 45, because it's right next to 135 in its favor. So Y, so basically it's gonna be 180. Now, however, what is? Oh, no, that's correct. No, you're doing the answer for that one.
45 degrees.
The first one.
Oh, I'm sorry. No, you, sorry, I thought you were down here. My apologies. Let's talk about this one. Oh, this one. Okay. Let's go part B. Sorry. Part B. Oh, okay. If B equals 60, what else equals? Okay. Okay. B equals 60. What else equals 60? My apologies. So that's is so we'll definitely see. No, A is gonna be 120.
X equals 45 though.
Because B is 60.
Why?
Correct. Yes, you can say X equals Y
No.
equals C equals 60.
I feel like Y equals 45.
And then, which ones will equal 120?
Yeah,
Which ones will equal?
I will. Yeah.
Correct. Yeah, that would have happened, yeah, that's was.
What?
Correct. Now, let's talk about.
Yeah.
So you got Y, yeah. How do you get that? Do I have enough information here with access to? It's equal to Y. But why these lines parallel? But do I have enough information? I don't. So actually, we don't know. You can guess. What do you want to guess? Maybe it's 45, maybe 50, maybe 55, could be 61.3243. I've got those. But we still don't know. Actually, still. You want to try the other two? I'm gonna try to. Yeah, how are we doing here? So.
Yeah, let's be fair.
The only thing that. So. That's what I was.
Yeah.
Stay at my house last week.
Yeah.
Yeah.
Yep.
Okay.
Okay, for those who are at sports, you need to go to sports. I'm recording, so you guys can leave since, if we got sport, we'll leave. You gotta go. Okay, so let's talk about the rest of these answers here, guys. Here we go. Oh, geez. All right, so for part B, X, Y, and C are 60 degrees because you already know angle B was 60 degrees. And then for ADWZ, each was roll 120. Okay. Then for the diagram on the bottom of the page, X was 135, Y was also 135. Remember, X corresponds with 135 in the first diagram. These correspond to each other as we talked about up above. And X, Y are vertical, those are the same. Now, that's 45 because it adds up to 180. This plus this has to add to 180, so 45. But I have no clue what to make of this. But I just don't know because this and this are not parallel. So I just don't know. I mean, X could be made 50 or 4, 6, I have no idea. Yeah, here X is definitely 135 correspond, Y to 45 because it's right next to it. Here X is 45, of course, straight angle, but Y I have no idea. Not enough information. And that's the one big thing in geometry is we always have to have enough information to make the next step. I just can't make that next step with Y. Maggie, go ahead.
Will that be on the test where it's
Yeah.
like we can't solve it?
Yeah, and I'll ask you why. Yeah, 100%. Yeah. Yeah, it's would it be like, Maggie? It'd be more like a true false question. Like, true or false, I can find what this is, or it equals this, or whatever. Or another good way could be like, this must equal this, or this could equal. Like, must it be this? Well, no, I don't know what Y must be. I don't have enough information. All right, let's keep moving to 2.1.3. We're not going to get all this done today, but that's okay. So for 2.1. There's a second half here. You know what? The more I think about it, I think I'll save 2.1.3 for our next class. Let's finish off the second half of this. So let's finish off EF and 218, and then we'll be done because we got 235 today, right? Yeah. So I think it's fine. Then we just visit a couple minutes at the end. We can just relax. Okay, for E, answer Frank's question. Do corresponding angles always have equal measure? The answer is no. If not, when did their measures equal each other for parallel lines? Only when we have parallel lines are the corresponding angles the same. So just to recreate one of the diagrams from before, remember we had this diagram right here on the previous page where that was X. That was 135. And that was Y. So these corresponded with each other because they're in the same position, but were they the same? Not necessarily. What had it been true to make them the same? I had to take that line and rotate it in such a way so that it was parallel. Now, if these are parallel, would X equal 135? Yes. So now you see, when they're parallel, yes. Or not, I don't know. Or it's just not. So now we're going to use this big term of, we have someone else read. Faith, can you read part F, please?
If then. The statement in if then form is called a conditional statement. They are structured in the following.
Sure, yeah.
If hypothesis then conclusion or hypothesis.
Yeah. So go ahead and read the next one too, if you don't mind.
Right.
Yeah, and that's a true statement. It's it's a condition. Or I could say if my kids go to bed at midnight, then their basket case is the next day. That's true. Or if I don't eat lunch, I'm gonna be really cranky from afternoon classes. That is very true. Um, so those are hypotheticals, right? Do I hypothetically want to push that? Do I hypothetically want my kids to stay up till midnight and find out how the next day is going to be? No. Do I hypothetically want to skip lunch and then try to teach my classes? No. Now, if I said, if I get 8 hours of sleep, I'm going to have a great day next day. Yeah. Hypothetically, if I sleep well. So you guys get the idea. These are hypotheticals. These are more interesting ideas than geometry, but you get the idea. So we're going to do a hypothetical for this here. Let me type this up. If two lines are parallel, and there's already a comma at the end, then corresponding angles have equal measure. And let me actually, well, you need a transversal also, but I think that's implied. That's fine. If two lines are parallel, the corresponding angles have equal measure. So there you go. Now let's finish it off over here. Okay. So what's happening here? William, can you read 218, please?
It is not possible. Explain how you know. State the relationships you use. Be prepared to justify any measurement you find to other members of the team.
Okay, so I'll do the first pair or the first diagram. I'll have you guys do the second and third, and then we'll wrap up for today. So here's how I'm going to model the process, what I want you guys to do. I'm going to call this angle A. I'm going to call this angle B. And I'm going to type up something here. So I'll say angle A equals 115 degrees since they correspond to each other. Then angle A corresponds to angle B. So angle B equals 115 degrees. Another thing we need to keep in mind also, okay, so very important, you have to have parallel lines to make that connection. These lines are parallel, those correspond, they're going to be the same. These lines are parallel, those correspond, they're going to be the same. So it's a chain reaction. A equals 115, A equals B. Now, lastly, angle X equals 65 degrees. Yeah, good. 65 degrees because it forms a straight angle with angle B. I know I'm a little long-winded in the way I wrote it, but it's kind of good to do that because that's really when you become a better learner. And I'll admit, I wasn't this way in high school. I wasn't even this way as an undergrad. Not until I got to grad school, I got to be more this way. But, that's just some people live much later in life with their learning. But that was me. So I wasn't quite this way as a high school student. So I understand if you're not going to be as verbose as this, I totally get that. But, the more descriptive you can be, the better you'll learn because you're making those connections now, right? So we see this chain reaction 115 is A, so A is 115, A is B, B is also 115. Okay, now X has to be 65. So now we're gonna try to do the same for the other ones, if it's possible. If it's possible, and we'll state why if it's not. And remember, you have to have parallel lines for corresponding angles to be equal. So go and try the second and third pairs, and they'll wrap up. You're gonna collect, yeah. Sure, yeah.
You have to like write all of it out. Like you.
Whatever you're comfortable with. I'm not too picky about that. Oh, shit. See, this is off. That's correct. You can't. Second one can't be done, guys. Right. I'll where's my screen? So that's what you say for the second one. Keep it pretty simple. You know, that's 53 that I just marked up, but we can't determine what x equals since the line it is on is not parallel to any of the lines. So we don't have enough information, unfortunately. We can't make sense of it at all. Yeah, Connor, go ahead.
You don't have to like apply it to any of the angles.
No, not at all. No. Yeah, so for the third one, I know I'll call this A, for example. I'll call this B. So it's kind of a chain reaction, right? 3x plus 10 degrees equals the measure of angle A. Those correspond. Also, the measure of angle A equals the measure of angle B. Those also correspond. And the measure of angle B equals 4x minus 25 degrees. Those also correspond. So these are all corresponding, or actually, that's vertical angles. My apologies. So it's a chain reaction here. These are the same, those are the same, those are the same. So if you use A and B as a bridge, you kind of see this connection now. What can we prove about 3x plus 7 4x minus 25? Those are also the same. Those are also the same. So with that said, and I can solve for x. 3x plus 10. And this is what we actually call a proof. I proved this. I made a proof by going through this logical steps. And that's geometry. This is the essence of geometry in many ways. It's a logical flow. The flow makes sense. X equals 35. Now in life, sometimes it doesn't happen. If I were to say, well, the 49ers beat the Seahawks, and the Seahawks beat the Bills beat the Chiefs. So the 49ers are going to beat the Chiefs. No, we can't beat the Chiefs in Super Bowl. We keep losing to them. So that's my dumb football joke for today. But obviously it doesn't work that. But in math is more straightforward and more concrete. Yeah, that's what happens. And so we see that has to be true. So X is 35. Okay, cool. We're all set. Perfect timing. So homework I'll post to Schoology. Yeah, I didn't print it. I'm still kind of behind in getting stuff done, but I'll make sure I'll take care of that for you guys. And that's all for now.